talking about the online analytical processing operations. There are a number of operations that can be performed on this multidimensional structure. Like we have seen in OLAP, we store our data into a cube, multi-dimension cube. So what all operation can we perform on this data? The very first operation that can be performed here is the roll-up or drill-up. Roll-up operation, we can also call it drill-up or the aggregation operation. It performs the aggregation on the data cube by climbing down the concept hierarchy. That is a dimension reduction. Like if you see roll up, it is like a zoom out option. If you zoom out, what do you see? You see something specific. All the other dimensions, they are cut off. If you see the camera and you want to zoom out, what happens in zoom out? A particular thing that you want to focus on can be displayed, all the other things will be discarded. So similar is the operation of roll up. It is like zooming out on the data cube. So this, like we have the hierarchy for a location. If we talk about the location, it will be defined as the street. It will be defined as a city, any particular province or a state or a country. There are different hierarchies of the location. Now, this roll-up operation, it aggregates the data by sending the location hierarchy from the level of city to the level of the country. So, when a roll-up operation, it is performed by the dimension reduction, one or two more dimensions, they are removed from the cube. Like, as an example, we can consider, if we consider the sales data cube having two dimensions. Now, our sales data cube, it has two dimensions. One is a location that we want to analyze. Another is the time, that at what time dimension do we want to analyze. Now the location we want to analyze, it can be in the form of, we want to analyze a particular city, we want to analyze a particular state, a particular country, or what. It is in a hierarchical form. Similarly, we have time. We want to analyze the sales of a day, of a week, of a month, or how. So the roll-up, it may be performed by removing the time dimension appearing in an aggregation of the total sales by the location, relatively, then by the location and by the time. So as per our requirement, if we want to analyze the data, we can analyze it with the help of reduction in the dimension of data. So the very first operation that our OLAP help us in performing is the roll-up operation or drill-up, also known as aggregation performance, which works in a very similar way like the feature of zoom out, dimension reduction, removing extra dimension and just focusing on a particular part. So that is what is this roll-up operation on our OLAP. The second operation, that is drill down. Drill down, it is also known as roll down. The first one that we talked about was roll up. Now we are talking about the roll down. It is just a reverse operation of roll up. In drill down, it is like zooming in on the data cube. So it navigates the data from less detailed record to more detailed record. Like if we have analyzed the data for a day, now we want to analyze the data for a particular week. And we want to analyze the data for a particular month. So that is what is zooming in. So the drill down, it can be performed by either stepping down a concept hierarchy for a dimension or adding some additional dimension. Like we can analyze our data on the basis of location. Now we are analyzing the data that at this location, this much is the sale of the product. Now we want to add one more dimension, that at what point of time sale is more. So we can add one more dimension into it, that is the time dimension. If we want to add one more dimension is that what kind of items are sold more. So that can be added. So drill down operation, this is just the reverse of our previous operation, which was drill up. Drill down, it appears by descending the time hierarchy from the level of quarter to a more detailed level of the month. Because our drill down, it adds more details to the given data. It can also be performed by adding a new dimension to the cube. Like a drill down on the central cube of it can be introduced by using an additional dimension. Additional dimension, it can be the time, it can be the location, it can be any particular group of customer, it can be any particular type of products. So if dimension is added into the cube, that operation will be known as drill down. So the first one that we saw was drill up. The second one that we are talking about is drill down. Drill down means adding more dimension, and drill up is focusing on any particular thing, removing the rest of the dimension. So this is the second operation that we can perform on our OLAP software. Now, after these two important operations, which is roll up and roll down, we have three more operations which can be performed on our OLAP software. That is the slice operation, the dice operation, and the pivoting operation. Talking about the first one, which is a slice operation. Slice, it is a subset of a cube. Like we have a whole multi-dimensional tube in which there are a number of dimensions on the basis of which we can analyze our data. Now we want a subset of the cube corresponding to a single value for one or two or more members of the dimension. For example, a slice operation, it is executed when the customer wants a selection on one dimension of a three-dimensional cube, resulting in a two-dimensional site. Like if the customer, he does not want to analyze, he does not want to go about the whole dimension of the product. If he is purchasing a product, he wants to know that by which company has this particular product be produced, in which has come into your supermarket. He does not want to know more and more information about that company. He does not want to know the packaging rate of that particular product. He does not want to know more dimension. So, for making a subset of the cube, what does he want to know? He just want to know about one dimension. So, for that, we make a slice of the cube that is called the subset. So, the slice operation, it performs a selection of one dimension of a given cube. Thus, it will result in a subcube. Subcube means we have the whole cube in which the entire information is stored, but we create a small cube of it which will be known as a subcube. On this subcube, the data will only be as per the requirement of that particular analyst, that particular customer, that particular executive, or whosoever has asked for that particular information. So, slice, it is a subset of a cube. Now, talking about dice, the dice operation, it will describe a subcube by operating a selection on two or more dimensions. So, basically, this dice, it will describe a subcube by operating a selection on two or more dimensions as they are required. Now, we have the third operation here, which is pivot. The pivot operation, it is also known as rotation. So, pivot, it is a visualization operation which rotates the data axis in view to provide an alternative representation of the data. Means it is rotating the data. It may contain swapping the rows and columns. Like we have particular rows, we have particular columns. We want to swap them. We want to view the columns here and the rows here. So we can swap them. Or moving one or more row dimension into the column dimension. We have certain data into the row dimension, but we want to analyze it in the column dimension. So, certain rotation of data for the purpose of visualization. If we want to visualize our data in some different format to make better analysis of data by ourselves. So, that kind of operation will be known as pivot operation. Pivot also known as rotation, because what we are doing, we are just trying to rotate the data to make ourselves analyze the data in a better way. So, pivot, it is a visualization operation which rotates the data axis to provide an alternative representation of the data. Rows and columns, they can be swapped, or one or more row thing can go into the column thing can come into the row. So, that is a form of rotation that we can perform. So, pivot, it is a visualization operation. So, these are the few operations that can be performed on our multidimensional cube. So, the 5 basic operations that we perform on our OLAP is the roll up, the roll down, slice, dice and pivoting. Now, understanding the term cubism. Our OLAP cube, it is a multi-dimensional array of data. OLAP, it is a computer-based technique for analyzing the data to look for the insight. The term cube that we are referring to here, it is a multi-dimensional data set which we can call hypercube also, if the number of dimensions are greater than 3. In a cube, we can see it is a 3D architecture. But if the dimensions are more than 3, we require more of dimension, then we can also call it as a hypercube. So hypercube, it is another term which can be related to our cube. So a cube, it can be considered a multi-dimensional generalization of 2 or 3 dimensional spreadsheet. Like for an example, we can say if a company, he might wish to summarize the financial data by the product or by the time period or by the city to compare the actual and the budget expenses. Now the product, the time, the city and the scenario, these are all the data dimensions. We have different dimensions of data depending on what that product is, depending on what time that we want to analyze the product at, depending on a particular city, depending on any particular scenario. So these are different data dimensions which can be represented with the help of cube. Cube, it is a shorthand for multi-dimensional data set. Given that data can have arbitrary number of dimensions, we can see that our data, it can be analyzed on the basis of different dimensions, on the basis of different perspective. So the term hypercube, it is sometimes used especially for data with more than 3 dimensions. If it is having 3-dimensional data, then we normally call it cube. If it has more than 3 dimensions, then at that point of time we can call it hypercube. Now we are calling it cube, but a cube, it is not a cube in the strict mathematical sense, because in a cube what we see, all the sides of the cube are same, but the sides, they are not necessarily equal. Here if we talk about OLAP, there can be more columns into the time dimension as compared to the location, or there can be more location as compared to the product. There can be more products as compared to the time dimension. So it is not exactly that all the sides are same in a strict mathematical sense, but because the structure, it looks like a cube, so we can call it as a cube. But we have to understand that here the sides of the cube that we are analyzing in our OLAP, the sides, they are not necessarily equal. For our time, we can have day, week, month and year. But location can be many. It can be divided into Delhi, Calcutta, then we have Mumbai, then we can have Bangalore, then we can have Chandigarh, so there can be number of locations. So it is not sides are necessarily equal. So cube here basically, it is a multi-dimensional data set which will represent an arbitrary number of the dimension. Now, talking about OLAP tools. OLAP, many tools have been produced by different organizations. Many OLAP tools have been produced. If we want to name some of the tools that are being produced by different organizations, the first one will be the IBM Cognos. It is an integrated web-based analytical processing system which is owned by IBM. IBM Cognos. It contains a toolkit to perform the analysis, perform the reporting and the scorecarding along with the provision to monitor the metrics. So this is a one tool, IBM Cognos, which is produced by IBM for the purpose of analytical processing, to perform the analysis, to make the reports, to perform the scorecarding and to monitor the various metrics. So the very first OLAP tool that we mention here is the IBM Cognos. Second tool that we can discuss about is the integrate.io. It is a complete toolkit for building the data pipelines. It provides the features to integrate, to process and to prepare the data for business intelligence. Now it has the coding in the form of low code, and even it provides a no code capabilities also. So integrate.io, it is another important toolkit that can be used for building the data pipelines. This is the second tool that can be used. Third we have here is a MicroStrategy. MicroStrategy, it is a Washington-based company which provides the services on the business intelligence and the mobile software worldwide. MicroStrategy Analytics, it enables the company or the organization to analyze a large volume of data and distribute the business-specific insight throughout the organization securely. So MicroStrategy, it is another tool which can be used for the analysis of data, and it enables various organizations to analyze a large volume of data. So this MicroStrategy, this is another tool which can be used for the online analytical processing. Our next tool that we have here is Palo. Palo, it is an OLAP, multidimensional online processing server. It is used as a business intelligence tool for various purposes like controlling and budgeting, etc. So Palo, it is a product of Xerox AG. So these are few tools like the IBM Cognos, the Integrate.io, MicroStrategy and Palo. These tools, they can be used as per the requirement. They can be purchased and used for the analysis of data into our organization. Now there are some more important tools here that we are going to discuss. Apache Kylin. Apache Kylin, it is a multidimensional open source analytical engine. It is designed to provide the SQL interface and OLAP in synchronous with Hadoop to support the large data set. So Apache Kylin, it is another form of tool that can be used. Then we have another tool that is a ICCube. It is a Switzerland-based company. It owns a business intelligence software of the same name, that is ICCube. It sells an online analytical processing server which is implemented in Java as per J2EE standards. There are all these tools, they have to be built into some particular language. Different programming language, different coding language can be used for this. So this one, ICCube, it has been built in Java as per the J2EE standards. As per their standard, it has been built. It is an in-memory OLAP server and it is compatible to work with any data source that holds its data in the tabular form. So this is another tool which can be used for our online analytical processing. Then one more important tool, that is Pentao. It is a powerful open source tool which provides the key business intelligence features like the OLAP services, like the data integration, like the data mining, the extraction transfer load that we've seen, ETL, also provides the reporting and also the dashboard capabilities. So it is another powerful open source tool which can be used. It is also built on the Java platform and it can work with Windows, Linux and Mac operating system. Any of these operating systems, they can use this Pentao tool. So we can run this Pentao on any of our operating system and make usage of the various OLAP services like integration, like the mining of data for the purpose of reporting, for the purpose of dashboard capability. This can be used and it is an open source tool, so we can easily use it. So these are few of the online analytical processing tools that we can use for the analysis of our data of any particular organization.